Welcome. Let's take a look at finding the critical points of f of x equals x times the square root of 16 minus x squared. Recall that when we're looking for the critical points of the function, there are two things we have to consider. We have to consider where the derivative of f is equal to 0 and where the derivative of f is undefined. So to find the critical points of our function, the first thing we need to do is to find the derivative of the function itself. So let's go ahead and do that. So f prime of x is equal to, notice that we have the product of x times the square root of 16 minus x squared. So we will be using the product rule. Derivative of x is 1. Times the second function, which is 16 minus x squared, plus the derivative of the 16 minus x, square root of 16 minus x squared. Recall, this is the same as saying 16 minus x squared to the 1/2 power. So our derivative is going to be 1/2 times 16 minus x squared to the 1/2 minus 1, so negative 1/2. And then, because our argument is 16 minus x squared, we're going to have to use the chain rule, so we will multiply by negative 2x. That's the derivative of the second part of the product times the first part of the product, which is simply x. Now note that this 1/2 and this 2 will multiply to give us a 1. And this negative exponent will move the quantity 6 minus x squared to the denominator. So f prime of x is equal to the square root of 16 minus x squared. We do have this negative and x times x. So we'll have a minus x squared over the square root of 16 minus x squared. Now, keeping in mind that we need to be able to find where the derivative is 0, let's go ahead and create a common denominator and combine these two terms. To do that, I'm going to have to multiply our first term here by square root of 16 minus x squared over square root of 16 minus x squared. So that's going to look like this. So f prime of x equals 16 minus x squared times the square root of 16 minus x squared over square root 16 minus x squared minus x squared over the square root of 16 minus x squared. So that leaves us with our derivative being, so our denominator is clearly square root of 16 minus x squared. When I multiply these two square roots together, I end up with simply 16 minus x squared, minus then the numerator in my second term, which is x squared. So f prime of x ends up being 16 minus 2x squared all over the square root of 16 minus x squared. At this point, we're ready to consider where the derivative is equal to 0 or where the derivative is undefined. So first, let's consider where our derivative is equal to 0. So our derivative is 16 minus 2x squared over the square root of 16 minus x squared, and we want that to equal 0. Well, if I multiply both sides of this equation by the square root of 16 minus x squared, that will clear the denominator on the left and on the right I will end up with simply 0. So we would have 16 minus 2x squared equals 0. Now adding 2x squared to both sides of the equation gives us 16 equals 2x squared. Dividing both sides of the equation by 2 gives us 8 equals x squared. And then taking the square root of both sides of the equation, we get x equals plus or minus the square root of 8. And 8 is 4 times 2, so that's plus or minus 2 times the square root of 2. So we have two critical points from our derivative equaling 0. And now the second thing we have to consider is where is our derivative undefined. Now, when we consider where our derivative is undefined, we need to remember that critical points must be on the interior of the domain of the function. So the domain of our function here, because of the square root, we know that 16 minus x squared must be greater than or equal to 0. And that really only happens when the values of x are between -4 and 4. If a value of x exceeds 4, then I'm going to have 16 minus a number greater than 16, so we'll have a negative value in under our square root. So interior points means we're only interested in those critical points or points at which the derivative is undefined when they lie interior to that interval. Well, that means we're considering points that are bigger than -4 and less than +4. That's what it means to be interior to the interval. We have to exclude the endpoints. So in doing that then, if we look at our denominator, square root of 16 minus x squared, and we don't want that to equal 0. We need to exclude those values. If I square both sides of the equation, I get 16 minus x squared equals 0. And if I add x squared to both sides of the equations, I get 16 equals x squared. And if I take the square root of both sides of the equation, I get x equals plus or minus 4. Now notice, in the case where our derivative is undefined, we only want interior points. That means we only want values between -4 and 4. So we will disregard these 2 points because they are not interior to the domain. So we're disregarding those. So our critical points, we only have 2 of them, and they are x equals 2 square root of 2 and -2 square root of 2. I hope this is helpful.